Hello, this video goes over the formation of acetal and cyclic acetal from our carbonyl species. Acetals are formed when we have a weak nucleophile, ROH, and an acid to catalyze this reaction. Just like the formation of hydrate in acidic conditions, the first step is to prepare our proton donor, which in our case would be the ROH. ROH is able to deprotonate H2SO4 in order to turn into an OH2 plus group, just like that. So an ROH2 plus. Now, this ROH2 plus is able to protonate the carbonyl just like so, so that we have this product. Now we have a good electrophile that can be attacked directly by our ROH group as a nucleophile to form this intermediate. This is our hemiacetal intermediate. Now, this hemiacetal intermediate can be deprotonated by the same ROH species present in the reaction, just like so, forming this intermediate. In the same way, another molecule of ROH2 plus can protonate this hydroxide group, so that we are left with a good leaving group on the molecule, just like so. The two lone pairs come down and then kick out the leaving group, so that we form this product. This is now a good electrophile that can be attacked once again by our ROH species, the weak nucleophile, to give us this product, which is deprotonated once more, another deprotonation step, to form our acetal. Cyclic acetal formation is similar in that we need an acid to catalyze this reaction and an ROH species, which is a weak nucleophile. However, the ROH species this time is a diol, whereby we have two alcohol species on one molecule to form a cyclic compound, like so. The first step, which is the preparation of our proton donor, is the same as the acetal formation mechanism, whereby the ROH species is protonated to become ROH2 plus, which can be deprotonated by our carbonyl oxygen, just like so, to form a good electrophile that can be attacked by the ROH, just like so. Just like so. Then we have another deprotonation step, which is again carried out by our ROH. So this ROH diol we used is a proton donor, a base to deprotonate, and also a nucleophile, whereby we form this product. Then we must make this a good leaving group, and we do so by protonating it again by our ROH2 plus species, to form this product. Now these lone pairs come down, this group is kicked out, and we're left with this product. Finally, an intramolecular reaction happens where this hydroxide group attacks and the pi bonds break on this one to form this group. plus. And finally, we have a deprotonation step. Just like so. To give us our final product, the cyclic acetal. And this reaction, like most acidic reactions, is reversible using water that's acidic.